engineer friend call me today or text me and say, hey, Tool Time, Jeff Ostroff has got an FIU bridge video. Didn't you just ask about that in your survey about whether people wanted to do about FIU bridge? And I said, yeah. I said, so he sent me the link. And I didn't watch all of it, so even though it looks like it's fully there, I skipped it. This is the part that I stopped at in a section because he's trying to explain compression and tension in a member. Remember, Jeff's a computer. I don't know if he's still got a skill, not a cell phone engineer, not an engineer, not an engineer. He's like a sanitation engineer. He works cell phone engineer. No offense to any of you cell phone guys out there. If you are, I got some questions for you. Jeff can't even answer those questions because, as you guys know, the Titan had used cell phone signal to communicate with the type of system to communicate with the surface. And yet here's a guy with that degree is not revealing the smoking information about that. But now he's going to cross the line into structural engineering and is wrong. All right, guys. So he's 21,000 views this time. Let's see what it is when I click on it.
18.
And let's pause it. 21,000 views 3 days ago. Okay, he just sent it to me today. All right. So looking at the comments, yeah, these people are just being bedazzled by bullshit. Any engineer out here, you're going to know what you're going to see in a second is just like, what? What the hell is he pulling at? Listen. So I have about 8 tabs queued up on this. So first off, he stole my information again. Once again, hyena time. Here we go. Listen, and I'll show it to you. I'll prove it. Let me just state it clear. I'm the only one that stated publicly that Danny Pate said put it back to the way it was on Saturday. All right? I'm the only one who said that publicly. Over here, FIU Bridge number 11 could not push off number 12. Number 11 was already a failed member. All right, and then down here, somewhere I should have Saturday in here, put it back to where it cracked like hell, post-tensioning. I thought it was queued up, sorry guys. Denny Pate in the meeting told them to put the post-tensioning back to where it was on Saturday. All right, put it back to where it was on Saturday. Do you see that right there? Well, hold on. The report actually says, the OSHA report actually says the retention March 15, 2018 was worsened the situation as the shear plane. All right, that's that number 11 cracking. The force is there. And it tells you the kips it did. And nowhere on here does it say put it back to the way it was on Saturday. Danny Pate states to put it back. It says to put it back in a certain way. On March 13th, 2018, and on March 15th, FIG instructed the contractor to retension the post-tension bars in diagram number 11 to force of 280 kips each, incrementally, with approximately 50 kips retensioning at a time, alternating between the upper and lower post-tensioning bars. Nowhere in here does he state, put it back to the way it was on Saturday. I'm the only one that said it, because I had access to inside source that told me that. Nowhere, even the OSHA report nor the NTS report stated put it back to the way it was on Saturday. So he's once again this is this is me over here on Reddit. I don't use it much, but I try to. And so he's now using it. So I Google searched it too. Danny Pate says put post-tension back to the way it was on Saturday. And it turns out I'm the number one hit. And September 5th, 2023. October FIU Bridge Collapse Engineering Reddit, October 31st, 2019. Okay, and let's just do this real quick. All right, so I searched the word Saturday on this page, upper right here, and you see it? It didn't show up. So they just linked it to that. That just links to that. All right, but this one is my own publication, and we do the same thing. and Saturday's in there twice. Right. So there we are. They put it back to the way it was on Saturday. Now let's go to the guy who takes your work, the plagiarist. And then let's hit a couple of these links here. Plagiarizing is when you're taking somebody else's work without giving them credit. And I'll go to this video here. It's in members only. I'll go to that one also. Incidentally, I got kicked out of this group because I was supporting President Trump. I only just signed up for this only. But because I supported President Trump, they kicked my ass out in a hurry. So people that wonder why I'm not over there, that I've seen a couple comments, why doesn't he come over here and all? You guys I've never bothered to try to sign in on a different name or anything else. I found your group to be too far left. Because this person talked bad about President Trump right here as part of his argument about the FIU bridge. The trust me part makes me feel like I am dealing with President of the United States. This is 2018, guys. This will be Trump and this person. And I responded back, this doesn't belong here. It belongs somewhere else. And neither does my reply belong here, because it's not dealing with the engineering. And they kicked me out of the group totally. Oh, that person got to stay, incidentally. The Trump person. All right, so let's go to tool time right there. And right there, right here it is. Also, member 11 is going to be tension today, 3/15/18. That's what it says there. It doesn't say put it back to Saturday. All right? But what just off is missing is that, and a lot of people is that number 10 is where the forces were going down, which I talked about. And then this report came out, and yes, I agree, the forces are redirecting down 10, not 11. All right, let's go through this.
Are these guys crazy? What's going on here? So what FIG is trying to do is you have number 11 right here like this.
So this is what he's calling number 11. And then you notice it's a copycat of a version of copycat of my column. But I guess he's too cheap and he doesn't have a brain enough to figure it. It's two fucking post-tension bars. They use a blister bar up top, and it doesn't go on top like that. One goes through here, right about here, and the other one goes out into the column out here. But he's got this way over here with all this extended slab. All right, but so no, let's go for it.
Yes, and remember, they went through that whole design phase there.
Take note, the nut is tight now here and here. Now watch, whole design phase, listen, watch.
Of putting number 11 in compression. That's what.
So he said of putting number 11 in compression, all right, and he shows his hand in compression.
Where it is right now. Denny Pate, he's the engineer of record. He wants to loosen this guy back up and retension it, restress it, they call it, because
he wants to loosen it up and retension it. This guy's is he fucking crazy? Is he not? Is his brain just only about money making? Because he doesn't know shit about engineering. This is not what it was already detensioned. All right? They wanted to put tension back in it. Let's back that up again. This is what pisses me off right there, and I couldn't watch any more of his clown show. Watch, here we go.
We have number 11 right here like this. And remember, they went through that whole design phase there of putting number 11 in compression.
So how do you get number 11 in compression? You actually put tension in the post-tensioning bars, guys. But he doesn't know that. Now we'll fix it because he's watched my videos. All right, listen.
That's where it is right now. Denny Pate, he's the engineer of record. He wants to loosen this guy back up.
So he says Denny Pate wants to loosen it back up. All right, that's what he said, not me. That will loosen it back up. Where are you? Okay, this is the report, the OSHA report. Right. FIG instructed the contractor to retension the post-tension bars and diagram. This is what is stated right here. FIG instructed the contractor to retension. But yet he is a lie saying that he's telling him the detensioning it. Watch.
I have number 11 right here like this. And remember, they went through that whole design phase there of putting number 11 in compression. That's where it is right now. Denny Pate, he's the...
And that's false. That's not where it was at the time of collapse. It was in the detention mode. All right? Listen, you detentioned it on Saturday, and that's when the crack like hells appeared.
the engineer of record. He wants to loosen this guy back up and retension it, restress that they call it, because
So it's a lie. He doesn't know what he's talking about. This guy is, guys, call him out on it, please. He's a fucking cell phone engineer, and I'm not, I'm not
about why the cracks are
I'm not really knocking that. I'm just saying that he shouldn't be doing these fucking videos.
forming. So they want to put the bridge back into the same state that it was when it was next door in the casting yard. So you're talking.
So put it in the same thing in the casting yard. That is not what the report states. I showed you that. Denny Page says retention it there. Not when it was next door. I'm the only one that stated that. So he found my video and then did that because I'm the only one that stated that. He actually specifies specifically the different these kips. This here, the casting yard. It's physically impossible to put it back to the way it was in the casting yard. All right, what he calls for. It's physically impossible because the structure's got a new dynamic to it. It's cracked up. So that's also physically impossible. So again, that's me on Saturday saying put it back the way it was on Saturday. Let's go back here. Sorry guys for jumping the line on this one and not doing the other one like I said I would. Obviously some things trigger me, and this is one of them. All right. So let's do this again.
That's where it is right now. Denny Pate, he's the engineer of record. He wants to loosen this guy back up.
That's a lie, okay? Denny Pate, he's lying on Denny Pate, all right? Denny Pate is suing for this publication, saying that Denny Pate said loosen it back up. Denny Pate should sue Jeff Ostroff for saying that.
And retention it, restress it, they call it, because
he never said to it was already detention, guys. Now, here's the kicker. Here's the kicker of that. All right, so, how much more can I go into that? When you just got one lie like that, it just compounds, and I could spend too much time, so I don't fucking have the patience for that. Let's look at I just get the aggravation for it. What the hell is this queued up for?
Are these guys crazy? What's going on here?
Okay.
So what Fig is trying to
So he's calling them crazy, and he's the crazy one.
do is you have number 11 right here like this. And remember, they went through that whole design phase there of putting number 11 in compression.
Compression. All right. I did a video on number 11 going in compression. It's the engineer she called out. She did the post-tensioning, as I understand. She's the one. He had a sub-engineer working underneath of him. She did the stages, the steps of post-tensioning, how she wanted each wanted the I don't know if I want to give it away again. All right, so she actually post-tensioned number 11 and 2. Number 11, 11 would be this one, 11 and 2 first. So this is number 2 here, and this is number 11, it's reversed around. This is 2. And this is 11. I've done that before. I've gotten this backwards looking at the damn diagram, assuming right side of the structure. So I apologize. A couple of people corrected me, and they were you were right. I just keep flipping it around in my mind that this is the way I looked at the drawing. So the number 11, because in the drawing, number 11 is on the other side. So this is 11 and this is 2. What's hugely different about these two when they detension, and these you call blister bars at the top. Right here it just says blister. The diaphragms, that's where all this interaction goes between these two. A huge difference. This guy's like 4 feet. This is like 2 feet. It's a mega difference on each end. What's back there. Now, because they were transporting it with the transporter, is it an image here? They had to stop the ends from cantilever from falling over, from flapping over, and to do that. The transporters were here and here supporting the structure. They had to put tension in this number, am I getting this back? Number 2 and number 11. And that helps it hold it from falling over and breaking at the top. Once they put it in place, they were supposed to solid grout these also. They did not. It was one of the sequences. And and I'll say stages, but I do mean sequences. And the detensioning took place also of number 11 and I get that number 2 and number 11. Detensioning because it's already under compression. This is an entire compressor system. It's actually complementary, pretty fucking genius. Now here's the problem. They were ordered to do a contract ordered them to do a redundant system, and if you only give it saying it's compressive only, you lose the redundancy. So then they double dipped at the they had their engineer say that, oh, well, and Danny Payton, Linda Figg, I think it was Linda Figg stated that it's also a truss system. Now I'll give you the audio on that it acts as a truss system also. But it's all compressive, so it cannot be a truss system if it's all compressive, as she states. Truss systems have, reversals that take place. So it can't be that. She could say that, if I try to think outside and think differently, it acted like a truss system. Nevertheless, it behaved as one once the deflection started taking place. The deflection started taking place right here at 9 and 10 because this was cracked. After they detensioned it and they removed the transporters equipment, then the bridge sagged, and this was so rigid here. This was pretty fucking rigid. All this is rigid. You think it would break in the middle, right? No, it was pretty rigid. It almost made it out to number 11, but it couldn't. It was rigid right about here, and this is the part that dipped. When this dipped, this dipping slid number 11. Oh, that's what he did show. He did show 11 sliding. So let's go with 11.
That's where it is right now.
Let's see if I can find it. Come down.
He's the engineer of record. He wants to loosen this guy back up and retension it, restress it, they call it, because he's puzzled about why the cracks are forming. So they want to put the bridge back into the same state that it was when it was next door in the casting yard.
And I'm the only one who stated that. Only one who stated that because my inside source gave me that information. All right? Now, watch this sliding thing. This is what a lot of people believe.
See it happening, but it's going to happen over the course of 3 days. Okay, so this bridge is now in a slow collapse. So you have diagonal 11 is doing this very, very slowly. You don't see it.
This is what I always find funny about clowns like him and everyone that believes that number 11 can move. I don't care who you are. Number 11 is anchored here. Right? It's anchored at the top. And it's here. But magically, everyone just has this sliding over with nothing else happening with the bridge to make it just slide over. For this to slide over and push on number 12, it would have to dip. And the only dip we have is at number 10, per the video also. Plus, per Danny Pate's report. If you guys pay attention to it, some of you engineers out there, wake the fuck up. Wake the fuck up. Read the damn report and pay the fuck attention and draw your own conclusions. Just don't have your mind set to, I'm going to accept whatever this report says. As you get the data, call bullshit on it. For example, you should be calling bullshit on let's see, did I get the wrong tab? Let me close out this tab. Bullshit on this just magically sliding over like it's on a dance floor, doing a Michael Jackson move.
Whole thing.
All right, so that's able to slide over as he just showed, sliding over many inches. But this is all cracked to hell. This can't slide shit. Look at it. It's fractured fully through. It's also torqued. Now, any engineer that can't see this torque, you're a cocksucker. Look at the twist in it. All right, he's sliding a damn level thing down in it. He's sliding an 8-inch deep wooden stick presented to us as the wooden tape. Wooden shit. I forget the brick. Maybe it's a brick. Shit, I haven't used one of these in a million years. A line, brick. Anyway, so it's 8 inches down there, right? He's jammed it down there, and so that tells you this bridge is torqued, rotating clockwise or combination. But I think it's clockwise if I remember right. As we look at it from here, from where we are, if we could stand here and look at the face of this, I think it's clockwise. So the top part's clockwise. And we see that because we don't see the cracks right there. So this and this is behaving the same, twisting. What would allow it to twist like that? Well, they put 2 damn divisions in there, a control joint, if you will. 2 post-tension bars right down the center of that son of a bitch. Now, right down the center there, one there, A and B. I forget which one's A and B. I think one's longer than the other. All right, there are two of them, and it rotates. All right, when they detension, this son of a bitch cracks like hell. It rotates, telling you that this bridge is not in equilibrium with the what? With the post-tensioning that was applied and the spans. That it twisted. It's a long-ass beam that twists. All right, you guys can see it with the airplane hanger, that buckling and twisting, right? Torsion buckling. Why can't you see torsion buckling in this bridge? Why must you accept the fake narrative that this just slid over?
Thing is, it's collapsing right now. It's basically, you don't see it happening, but it's going to happen over 3 days. Okay, so this bridge is now in a slow collapse. So you have diagonal 11 is doing this very, very slowly. You don't see.
It's just magically moving away from the blister bar, and the bar is there. Steel bars is moving along, and yet when they go to post tension it, they didn't say, "Oh, we got to go over 3 feet." The thing slid over 3 feet. No.
See it happening, but that's essentially what it's doing until it's going to blow out like that. Here's a better.
All right, so this is all bullshit. So he doesn't know what he's talking about from here. So let's go back to. So let's delete that, and let's go to. This is what Denny Page said. On the 15th, FIG instructed the contractor the retention, not like Asshat just said that it's going to be. It's already. To untension it. Let's go back to that. Right here.
Tensioned today, 3/15/18. Are these?
So he read it and doesn't understand it.
Here. So FIG says here in the meeting.
Also, member 11 is going to be tensioned today.
So member 11 is going to be tensioned today, 3/15/18. Are these guys crazy? What's going on here? So what FIG is trying to do is you have member 11 right here like this. And remember, they went through that whole design phase there of putting member 11 in compression. That's where it is right now. Denny Pate,
that's false. It was not in compression at that point.
The engineer of record. He wants to loosen this guy back up and retension it, restress.
He thinks that's what retention means, to loosen it up. What a fucking asshat. Stick to your damn running around Home Depot, man, or Lowe's or whatever. All right, so it stays here. And the retention on March 15, 2018 worsened the situation at the shear plane. All right, so retensioning will put compression in it, guys, not loosening up as the clown show just showed. All right, and now let's go to this. This is number 11. It's an A and B, and I forget which one is B and A, but one's low and one's high. That's the rod. It's lower post tension bar of diagonal 2 sheared. Now they quite a few people had, or at least I did, had a pissed about this, that they say sheared, make it look like it sheared off as in concrete. That's obviously a torch or a bandsaw that they did that cutting with. That cutting was done because we saw this in place, bent over. So they sheared it themselves, but they being nefarious with just making it look like sheared. The deck remains intact. Okay, so the deck, it slides. All right, so here's part of that number 11 upright. This is the number 11 here. And remember I think I can do better. I think I can do better in one of my tabs. Give me a second. Bear with me, guys. That's going to be a good audio for you there. So here's the number 11 here. And as you can see, it's an A and B deal right here. The configuration. This is A and B. And it's not a single bar. And they go through what's called a blister bar. And they bypass. Here's number 10, bypassing there. And they share this blister bar. Here's the top part, it would be A or B. You pick your poison. The lengths are just a little bit longer, and over here is where it connects to the outer part of the diaphragm. As you can see, this has that piece that hangs over, that little nub that hangs over. We'll show that. But over here on the number 2, when they detension it, it's way out here. It's got a lot of it's fully supported diaphragm down here, not partially, not with this little scab of concrete. This is a full, huge ass. I would call something like 4-foot diaphragm, and this guy's like 2 feet. I would call it much smaller in width. and it has a much larger base. See, from here to here, much larger than this little teeny guy here. It's got a lot more concrete. See how it's skimming right here, right there, if you can look at it, and then look at the clearance here. This upright, this diagonal number 2 is huge compared to number 1. That drove me crazy. Initially, I did a video on it. Everybody said that I didn't know what the hell I was talking about. When I first did my live videos on this, that it's a truss system. And I kept arguing, no, maybe this isn't a truss system. Maybe this is somehow a plate, you know, that holds it. And maybe I said, maybe the roof is supposed to help hold it stiff. And then all the loads go down here. The zero force member becomes a load-bearing column. I was thinking in that format. It was very difficult to work my way through it. Especially since we had the wrong diagrams initially, but then they cleared that up. We reportedly got the right ones, the correct ones, with the stamps on it. So that was publicly made available. So now we have this they transport it, and when they detensioned this number 11 here, which would be these two here, 1 and 2, they detension it. It fractures because this dips down. It dips down right here at number 10. We'll get to that. Let me finish the hell this up. Why do I have this queued? Let's see. Is that they told him, VSL told Denny Pate that the images he was receiving by cell phone, guys, he was receiving the images by cell phone from the bridge. All right, so this is showing me, I put this up 5 years ago, and I'm stating what VSL stated to Denny Pate. Into the meeting. And Denny Pate was saying, post-tension, continue anyway. Put the bridge back to the way it was. Denny Pate said, no, continue post-tensioning. VSL had a round 2 with the comment saying, no, it's worse. The images don't do justice to this, basically paraphrasing now, that they're worse than the images show. The bridge is worse. Denny Pate, still ignoring it, and I'm getting my paraphrasing, but correctly, put the bridge back to the way it was before the post-tensioning was released. This is what was going on in that meeting. So this is my current release. I'm going to leave that. All right, so that was way 5 years ago, right? Let me just move this out of the way. Now I'll delete it. I mean, stretching. Cantilever possible cause extra elongation. Right, that makes sense. Let's go to 1310 here. Concern. Oh, right here. Fig mentioned that no repair should be done. Once back span is there, that's the other span, right, guys? The other span, the 2 spans. Member 11 will be decreased. Then repair can begin. Will decrease. Fig also state that the prudent action is to share the load carried to 910 and construct pylon diaphragm. All right, share the load 910. This is what I've always stated, that it's 910. You know, and I did a model of this for you guys, just so I don't even know how I do this roughly. And I show you that, you know, I compare. I'll put links down below, and I'll show you where we do things where I do the back and forth. But I show you how I put in the deflection here. If this deflects down, once you detension that, see, that's totally detention now. You can see where that would want to drive down, and why the shims were called for underneath for this was to lift it, was to stop it from going down. Then I created a full fracture here in one of my models to show you what would happen, because it just can't push. All right, it's a full fracture. It's a broken leg. You can't walk on a broken leg. You can't make a fully fractured column do any action. And I left this part on because it's secured to the deck. But when I deflect, put loading here, we see that it then, you know, might be some bypass there, right? And the and the fracture happens there about there. Now I'll give you all the models of that. And then once I put it back in and I secure it, pulling it back in with post-tensioning, this would be like the intent of Denny Pate. Let's see if I can get it, if I do it, pull it back in on this one. Once I pull it back in, come on. All right, so I pull it back in. This secures it now that the post-tensioning would to pull this back together. Now if you load it, it can't move. It's bound. And that binds it, allows it to, but you see we got a torque issue going on here. This is the torque I show you in the diagram. And, well, that's part of the issue, isn't it? Let's go to this is me on top of it. I mean, I literally stand on top of the model. And I go over... Okay, ladies and gentlemen, what I did was let's do this. And again, I'm showing you what happens when the bridge deflects around 10. Is that this can rip away because it doesn't have... Only thing that's holding it together is that little bit of rebar reinforcement there in the diaphragm action. But you're going to get your split. And remember, part of this went down and part of this blew in half. Georgie? Oh, Bruce. 4 years ago, Bruce. Oh, there's the small scale I make. Bruce is going to help out and attack it. Thank you, Bruce. So we put a diaphragm there. All I do is put a piece of steel underneath there. And then I climb on board. All right, this is totally disconnected right here. All right, not connected. Watch it. Oh, well, what the hell? Well, what the hell? Do you notice it didn't go flying off anywhere? I totally have this disconnected because I have the steel there. I showed you that. It's not connected. It's not welded. I show you in another model too that it's not welded there. Maybe you can see it here. Here. Not welded. And there we go. You see it open the gap there. Let's put myself back on top of it again. Okay, so I climb on board of this system. And I also had steel post-tensioning bar at the bottom in one of my models. All right, you see it move? Nothing. Nothing. It's a rigid system. As long as this all stays interlocked. As long as it stays all interlocked, even this top one doesn't mean shit. As long as that bottom one stays locked. Why is that so important about the bottom one? Okay, the bottom one. Because the bottom one is still connected. This is going through the deck, still connected. The one up here is gone. Now remember, they say slide. Everyone wants to say slide. These are plastic pipes, guys. These are conduit. Here and here is conduit. It slid off the deck, blasting through all this steel. And look at the steel. Look at the position of it, straight up and down. Didn't bend the steel. It didn't fracture PVC pipe. All right. So no, it presents, and you want to think of slide friction, but it's not what happened. All right, it's not what happened. This deflected at 10, and that's indicated. Let me go fast forward. And there's the bottom. There's the bottom ripped off now, and there's that cable right here, the lower post tension cable that they said sheared. Clearly, it's not sheared. They cut it. So you got to be careful with that, and I think that's one of the things that got me in trouble with OSHA calling them out on that. Now D1, D2, D3, D4, D5, D6, all the way from left and right. So I forget how they do that, left and right. I think they call it, I forget how they call it, side this, side that. But these are post-tension less than, D1s are post-tension less than D2. And yet that's where the truss system goes down the middle of the structure, and that's the drain. The center drain they put down the middle of the structure. Brilliant, right? And so they have less tension on the post-tension cables that go from one end of the bridge to the next in D1s, and then compared to D2. So that just creates a deflection, a non-rigidity problem. You want this to be rigid. It's supposed to be all in compression, which I'll show you in just a hot moment. This shows you the rotations taking place because you have a lower side here and a higher side there. Torque. All right, it didn't just fraction pull apart. There's a rotation upwards. This is up, that's down. All right, the canopy rotated. There it is again. The canopy rotated. If they checked it for plumb, you'd have seen it was out of plumb. But did they do that? No. This is just from that rotation. This is what we would get the different elevations towards us, setback, if you will. I do a big deep ass dive into that. Now let's go into the yeah, this video is worth you coming to watch. This one here, I'm going to put the link down here. I'll put that down there. So let me move this to the far right so I don't use it again. Let's see what I got here. Him. I got that. I've got this. All right, so this is where the post tensions take place and what their calculations are instead of just talking about torsion. This I posted 5 months ago on whatever, trying to just bring up the topic again. I talk about Saturday. I give images, apparently. Okay. I don't remember. And now we have the FIU Bridge F. Denny Pate talks about 10. So he talks about number 10 right here, where I always talk about. Fig also stated that the prudent action is to share the load carried to 910 and construct a pylon diaphragm. All right, so he knew that those loads were going down 910. Not just sliding off at 12, all right? He knew they were going down 910, which I always argued about. They want to know if it's going to be permanent. He says no. This is a video that is 1 hour and 52 minutes long. It might be in a private group only. All right, let's jump to 3729. Let's listen to it out loud.
So you're going to maximize that durability.
This is Linda Fig.
Well over 100. I mean, it's going to be like 150 plus years.
She thinks the structure lasts 150 years.
So we don't want to encourage anybody to get on here.
No, I didn't say that. I mean on your over.
Up here.
Yes.
Oh, up here. Well, that would just be
Service
hatch.
A service hatch to get to the roof, guys. They want, how do we get to the roof?
Yeah, it's not be long.
But it's important. She said it's a 150-year bridge.
But you answered my question. There's a service hatch.
Yes.
For maintenance.
Yes.
Got it.
Yes.
Thank you.
Yes.
I was thinking public space.
Oh, let me back it up.
Too. I
Hold on, I went too far. 3723. It's an all post-tension concrete, so everything is in compression. Linda Fig, listen.
It's all post-tension concrete, so everything's in compression. So you're going to maximize that durability well over.
Everything's in compression. All right. There is no truss system that can exist, but there's conflicts in our statements because it goes different ways. Most sustainable bridge. Okay, her bragging about that. Why put cable stays? All right. So she says cable stays. Let's see what they say.
We bring Denny Pate. Denny is world-renowned cable stay bridge designer.
That's Denny Pate.
Denny has been with us for more than 35 years and has accomplished 30 one-of-a-kind cable stay bridges. This gives us the flexibility to do very unique things with bridges that are not only functional but aesthetically pleasing. And he has more hours in design on the Sunshine Sky.
Remember, guys, this is not a cable stay bridge, though. So she's blowing smoke.
Skyway bridge than any person, living or not living. It's exciting. We also bring you an award-winning team of a group of specialists who can accomplish.
All right, so MCM. All right, so watch this. At 3230, I say sounds like Denny Pate making fun of the design and saving Linda Fig.
Staircase was utilized for an event of some sort.
But to go back to what Linda said, at least one of the things you considered was a second 10-foot wide staircase that would go westward.
Yes.
But when you take 10 and 10, and you put them together, that's the equivalent carrying capacity of 20 feet.
Yes.
And it begins to approximate what's on the other side.
Just in a different configuration.
But you didn't include it in your plans. And so I'm sort of curious as to why you did it.
I'll give you one guess.
The steps were wrong. They had like one large steps compared to smaller steps on the other side. It had a volume transportation problem. So she states it's an all-compressive bridge. Also, cable stays at substantial stiffness. Listen to this.
Of the system, the cable stays adds substantial stiffness but very little weight, and the combination of those two is how we really got to achieving the 3 Hertz criteria. Drainage is a very important part of the project. We integrated that pretty much from day one.
So now, if you listen, he's stating that the cable stay, in this case, the steel tubes, are the part of the redundant system. That didn't happen, did it?
For the bridge deck, the drainage goes to the center, and then there's a central pipe that carries the water to the end of the project where it will be taken to ground and collected.
You understand that is the drainage system in the center of the deck. Danny Pate.
And then similarly, the upper surface of the canopy has a trough shape to it, which captures the water, conveys it to the project, and then down the last vertical member to the ground level for dispersion.
So the aesthetics has a lot of design inspiration. And this comes from the natural environment, technology and innovation, and educational excellence. Whether it's the origami antenna at FIU or...
Origami. Okay, so she said, let me put this in here now. It's kind of late. Origami design to match toy paper games. It's childish.
Or the Florida panther and the beautiful landscape. All of these things were used as things that helped us to be inspired
109th
about what
Street.
this bridge should be.
The height based off the street.
And so there's a lot of symmetry and rhythm. There's a uniform color of concrete, which is accomplished through the common source of materials. We have incorporated a blue canopy ceiling in the curved component that shields the walkers. This is because this is in harmony with the landscape of the sky as you look upward. And then...
So the curve of the skies, you look upwards. Curve of the skies, you look upwards for the canopy. So, I don't know. I don't see curves when I look in the sky. And so the curved design was not structural, in other words. All right? So the curved design of the canopy was not... Curved design of canopy was not structural. Of canopy was not structural. All right? It was sky design. All right, so there we go.
And the structural shape itself is actually a closed section, a very thin section that creates a slender ribbon across the roadway and the canal. What this also does is creates with the concrete a buffering for sound so that it's quieter for the user. Its functional bridge sculpture, the uniform ribbon of a slender deck, the origami feel associated with the open, varying strut layout, whether it's tighter struts as we go over the canal or more open as we go across the longer span of the highway. The tapering slender pylon really creates a dramatic centerpiece that tells you about the gateway that goes between both sides.
I'm going to punch that in right there.
It's a holistic design. And in carrying this whole garden experience across the bridge, the struts are like the branches, and then there are landscape elements along the sides at the edge of the bridge. And so in looking at walking this bridge and coming into this wonderful sculptural plaza, we enter the grand staircase, which is much wider, and it's got a curve. It's 30 feet. That curve matches an overlook, which is tied to the staircase. We have railing, which is a stainless steel mesh, but we used these stays.
All right, so look, they use the as she said, 30 foot there, and they were arguing the other side. What the hell, you got a 30-foot staircase, 15 on the other, 10 on the other side, or 20 on the other side, or some shit. So here we're going to take up with what she's going to say.
Allow us to do that. The whole frame system allows us to do that in a unique way. That's why we're integrating a truss and a cable stay structure all.
She says it's a truss and cable stay structure. All right, not me. She says that. We know it's no cable stay there. She's the engineer there. How come the hell she knows her bridge is not cable stay?
Was one unit, which
Linda, go back to the one day movement. All right, that takes that, now the next section to the north. Is that a second day, a week later, a month later?
That's going to be cast in place because we are out of the
We're gonna wait for
array
this.
of all of these items. And so it's much easier to take then the formwork that was used here and recycle that into this component here. Just
What she's saying is that they're going to use the formwork they used in the staging area to build this first leg, this first segment, to do the shit. My brain is done. Yeah, bridge. Yeah, my brain is done. Oh God. Really? You really? It's not a segment, guys. It's a. Yeah, my brain is done. Give me a second. The second approach. Oh shit. Give me a second. Let me put this play. Let my brain catch up.
just in a shorter.
So what's the time frame on that northern segment?
The entire casting of it?
Well, the installation of it, because I get the southern
Yes.
2/3 of it is one night.
Right.
It suddenly appears because you build it off-site
Yes.
and moved it.
Yeah, we're going to create a temporary deck to actually support the formwork and then cast it. It's probably.
I'm thinking of timing.
Mine-
6 months?
No, it's a few months. I didn't.
90 days.
Yeah.
So 90 days, plus or minus. So what you do is you swing the one bridge in place, the southern 2/3, and then another 90 days to pour the other one in place. And then at least the major portion of the bridge is in place, and you're working now on the landings thereafter, right?
The landings and the stays.
In the States.
These landings, right.
Okay, but those are installed by working on the already completed deck. So the strength of the bridge deck system and the roof, it'll carry all the loads, it meets all strength and serviceability criteria. The stays are really for the additional stiffness we need to be frequent. I have one last question that I wasn't expecting to answer. What is your towers called at each end?
At each end?
Yeah, where the elevators are located? What is that thing called?
The landing, the overlook tower.
Yes, an overlook.
Okay.
Overlook.
So that column of concrete that encases the elevator,
Yes.
let's call it the overlook,
Yes.
how do you get to the roof of that overlook?
Well,
No,
yeah,
we won't do territory 30 years later, when we
Yeah.
gotta re-roof it, short of,
Yeah,
there's,
yeah.
I'm sorry.
It's all post-tension concrete, so it's everything's in compression.
There she is again, 3728. Everything's in compression. So 3728. I'm going to say that. It's all post-tension concrete, right? She keeps saying it. Everything is in compression. That's a comma. So it is a combination. It's all post-tension concrete and compression. All right? Everything is. So when they detension number 2 and number 11, the deck sagged, and those members became in tension. They became in tension. What stopped them from collapsing, the bridge collapsing fully at that point, I believe, is that what was remaining, the remaining post-tension bar length grabbed hold. They act like an anchor, and that saved it from collapsing fully.
So you're going to maximize that durability well over 100. I mean, it's going to be like 150 plus years. So we don't want to encourage anybody to get on here.
No, I didn't say that. I meant on your over.
Oh, up here?
Yes.
Oh, up here. Well, that would just be
Service
hat.
Let's see this.
Side, because then it just naturally leads you into that area, and that's what. So we designed it based on the fact that that was a set criteria, and if we can work through that, certainly. I mean, we would have loved to have
Well,
on the ground.
I'm actually addressing the fact that on the Sweetwater side, the bridge, the staircase width is 10 feet. Something a lot less grander than the widths that you see on the FIU side. And even if you have to keep everything on the west side of the bridge, what flexibilities do you have when you go to construction plans to make them more equal, even if it's just in dimensions?
Yeah, so she made a 30-foot wide staircase on one side, but 10 foot on the other side. And they're supposed to have all types of conferences and, music and galas up there or something. All right, so this is, I might take it out of private, but just to show you that 9 and 10 is what he states here. 9 and 10 construction pylon right here is the major issue that they wanted to do the repair. He knew, Denny Pate knew the loads are being taken on by 9 and 10 in that meeting because he states it clear. Once back in there, number 11 force will decrease. Then repair can begin. Fig also stated that the prudent action to share the carried load to 9 and 10 and construct the pylon diaphragm. So I think he knew what was going on. I think he knew that, but he didn't. He thought that he could put post tensioning back in number 11 specifically, but 2 and 11 were supposed to be post tension. And it would crank it back up. It would pull it back in alignment, flat again. And maybe the photographs, his phone, remember his phone was put in a washing machine by his wife, and she ruined it. His wife does the laundry, and she put a nice cell phone in there. Steel channel, right, so that was ruined, and nothing came of that. I'm not even sure if putting a cell phone in what kind of washing machine that is that would destroy a cell phone. Let's see. Fig answer the temporary mechanism to capture the node preferred will not remain in the structure. Fig answer that the temporary mechanism to capture the node, that's 9 and 10, that's the load, preferably will not remain in the structure. This is what was going on. Remember, no grout was done either. Which was supposed to be grouted before the post tension was removed from 2 and 11 per the sequencing. Okay, so CEI of the job site to Fig question: will mechanism to capture the load from the node, that's 9 and 10, have to be integrated with the pylon diaphragm and will remain in the structure? I want to know if it's permanent. Fig answer that the temporary mechanism to capture the node preferably, not will, not must, will. It's preferably will not remain in the structure. Now, doing that, I had a little fun. I made a 9-10 node on that steel thing. I tried to see if I could capture 9 and 10, and it was not really possible going through that blister bar. You'd have to do a lot of exterior mounting, going back up to number 12, tie 12. You'd have to make a triangle truss. Here's number 9, 10. So, I'm just using this for a diagram, for background. So, no. So, a triangle, right? So, there we go. Fix it up. All right. So, you'd have to, this is 9, 10. Right here is 9. The fuck me, right? Okay, cool. Let me just do this real quick for you guys. Be patient. I'm going to wrap it up. So this is 9-10 node, right? 9 and 10 node. Okay, that's that one on the part of the bridge there. It's right there. Let's give it a color for you. And that sucks. And that would be this one. right there. And this is this is 12. All right. So this is 12 text. This is number 12. This is the upright. This is this. Oh, I wanted to do that. Yep. This is number 12. And over here is the one that's this one here. This here is the failed member. Okay, and let's just leave it like that. That's failed, and that's the nodal area. Let me do it this way. Maybe I got to go here. Yeah, I'll do that. So then this is 910. This is 1011, right? Let's do that. It's 1011, 1011, 910. Yeah. So then let's do that. So text. So this is 10 and 11 node. And they're called blister bars, right? That's what he titled them as. Now let's just blow off this blister bar here. Let's ignore it for the most part. Now let's recapture this back to the diaphragm here. There's a diaphragm. You need to get to the pile cap, the pure cap, big ass pure cap. Right, that giant ass thing there. There we go. And they were supposed to anchor this down too. That would help also. But if you could do and I'm going to see if I can change colors after I draw this one. Let's do this and let's do this. And now let's change the color to something that, like blue. Okay, that one works for me. So now if you can grab it here, come through the deck, make a steel bracket that would mount there around the entire blister bar area, securing it there. And then this is steel post tension bar. Of course, you would still use VSL. Now it's going to anchor here. It's going to want to pull down and compress on this side, and it's going to want to kick this over. It's going to want to pull it. Doing that, this is going to want to pull this out, kick it out. This, oops, and arrow. So how about I do this? This is one of the moments going to want to pull it that way, pushing it out. So then you got tied together. So now once again, you're going to make another capture. But look, we can capture it down here in the diaphragm. Okay, now we need to lock in because we got this moment thing going on there. So now we need to not lock this in so it doesn't kick out. So you might have to do a steel, I would say a steel hold on, a steel jacketed system around number 12. Okay, and now you locked it in, and this will be all steel now. Steel, steel, and steel. And now you're capturing that 910 nodal area, and now the force is trying to deflect 910. Can't do it because it's tied down here with the post tensioning bars that they used into the pile, the pier cap. The pile caps. Let's see, pile caps. This is up here, a pier cap, and then it goes right through the diaphragm. Here's a diaphragm here. It goes through there, tying it all in. Something like that. It would be pretty complex, but they didn't even draw up anything. They went right to post tensioning, and now 9 and 10, as they state clearly in the background here, 9 and 10 is very critical in making this diaphragm this work again. That's because they knew that this would only be temporary, but he must have thought that he could pull in the blister bar, and the deck would not fail. The canopy with all that load right here, the kips he was going to put on it, that he did put on it, was not going to fail. He really thought that this would just be a compressive bar, even if that it would be pulling it, cranking it back up. So you pull on it, and actually the force of pulling on it would make the this number 10 rise. And of course, make number 10 rise makes the entire deck, the remaining of the deck rise. If you can pull on that, it would be anchored here. So you're anchored here, right? That's the anchor point. Your post-tensioning is here. This is where the guys are working. And when they pull on it, he theorized, I think, that 9 and 10 would pull back up into place, this being an anchor point. What if it was bolted down? I mean, it's interesting. What if he could just, somehow make that anchor, almost go directly to his bar? Would that give him what he needed? Well, this would help. It needed temporary shoring and not poles, as Jeff Ostroff says. It would need shoring in the format of cribbing, wood cribbing all the way up. All right. With that said, I'll get you one piece, and you'll be blown away by this because I don't have. Hold on. People like to screenshot my screen, so I got to move stuff over. I don't care what they look at, stuff like that. I share what I make, so that's not important to me. I've been shadow banned for a while, guys. You guys can see that's why I appreciate your support. Oh, please, don't make me look at his face too much longer. All right. So let me do this. Shit. Nope. Trying to find you. Shit. Okay, here we go. Really? Give me a second. Huh. Well, I can't. This thing is so difficult to navigate sometimes. There we go. And yeah, FIU. Okay, time to get your mind blown a second here. Right now, oops, pause that.
Oh.
And ready for it? There we go. This is your surprise. This is the day of the failure, the day of the collapse. They were post-tensioning, as Jeff Ostroff states. They were loosening the cabling up, loosening it up. All right. That's a thread they're screwing on to grab it, to pull it up. There's the crane they have there to lift that heavy post-tensioning equipment. And that's just to connect it. There's the staging area part of it. There's the vehicles going through. And bam, this is the crew. All right, this is the crew that's up there. And this is the crew that's going to kill people below. But as I stop there, you can see that's what they have to get hold of. As I stated, they had to use a little chiseling here. That's not typical. They had to do a little chiseling to get back down in there. I guess maybe they closed the blister bar up, which doesn't make sense at all because remember they were going to detension it once it was in place. So when was this done? Well, obviously over in the staging area. And maybe some here also, because it's just nasty. I mean, you couldn't come up with a foam plug for this. I guess they said nobody's going to see it. Fuck it. Alrighty, screwing it on. That's a coupling. There's the post-tension equipment. Single rod, single hole. It's going to grab hold. It's going to pull this up. Pull the bar. It's going to add the kips. It's going to add the kips you asked for. They're going to go back and forth. 50-50, 50-50, There's, I think when I turn back around, it's about end of the video. Remember the guy that did this? He was on the bridge. He went down with it, and he just shared the video. This the safety line and down the middle that they would connect to. That's what a blister bar looks like. That's what also the holes for the anchors for the pipes that were going to go on there. 109 feet because it's 109th Street, I think it was. And that's hydraulic lines. You know, it's you step out of the way or not. This is where the rest of the tower is going to connect to. I think she called it something else. I forget. And they want to know how the hell they're going to get up to 109 feet to get to the roof to service it. And she was stumbling and said, "Oh, we'll put a hatch there." Well, somebody's got to climb up 109 feet. That's like, what, 10 stories? There'll be an elevator there, but it won't go up that far, so you're going to have to put some fall protection, staircase, what? You got a hatch at the top. That's, they got her on that one. Okay, see, he is connected. You know, his protection's on. Okay. Now, I believe this is VSL, guys. So VSL is supposed to be an export post-tensioning company. They're ready to put post-tensioning in that cracked member. Remember how cracked that member is? They're going to do it. That's the lower bar, and then there's the upper bar. They were just adding it into the last post-tensioning amount in the upper bar, I believe, when it failed. Okay, crane signal, it's right here, so no radio. And there's the secondary bar, the other bar. And they're going to tie into that. And I believe that's why I say it's VSL. See the back of the shirt? Vest.